Hey everyone, and welcome. Today, we're going to pull back the curtain on the invisible forces that cook up our weather. You know, those massive drivers in the sky that can take a perfectly calm, sunny day and flip it into a wild thunderstorm. So let's jump right in. So why does a beautiful, clear day suddenly turn stormy? I mean, it's a question every pilot has to ask. But really, we've all wondered about it. One minute you're enjoying smooth sailing, and the next, bam, the sky just changes. What's going on up there? Well, the answer is pretty incredible. There's a huge, invisible battle happening thousands of feet above our heads. All right, to get a handle on this battle in the sky, we've got to meet the main characters in our weather story. See, weather isn't just random chaos. It's actually shaped by these giant, invisible players. And we're going to get to know two of the biggest ones today. Okay, so our first main character is called an air mass. Now, just picture this. It's a massive bubble of air. We're talking hundreds, sometimes even thousands of miles wide, and the whole thing has the same temperature and humidity. It's got a consistent personality, you could say. And where does it get that personality? Well, it gets it from wherever it's been hanging out for a while. We call that its source region, and it's usually a big, calm area of high pressure. So let's break down the anatomy of these air masses. How do we actually describe these different personalities? Well, it turns out there's a really straightforward two-part naming system that tells us exactly what we're dealing with.
And honestly, this is way simpler than it looks. It's a two-letter code. The first letter tells you about its temperature. T is for warm, tropical air. P is for cold, polar air. Simple, right? Then the second letter, which is always lowercase, tells you about its moisture. M is for maritime, that means it's humid because it formed over water. And C is for continental, meaning it's dry because it formed over land. So if you see PM, what do you think? Polar, maritime, cold, and wet. What about TC? Tropical, continental, warm, and dry. See? It's a super simple but really powerful code.
But, of course, these giant air masses don't just sit still. They're always on the move. And this is where it gets interesting. As they travel, their whole personality can change, depending on the ground they're moving over. It's a process we call air mass modification. Okay, so this modification can go one of two ways. Let's imagine a cold air mass starts moving over a warmer surface, say a warm ocean. It's getting heated from the bottom up, right? That heat makes the air want to rise, creating instability. And that gives you those bumpy, puffy vertical clouds, cumulus clouds, that are perfect for creating showers. Now flip that. What if a warm, humid air mass travels over a cold surface? It gets cooled from below. That makes the air heavy and stable. So instead of rising, it just kind of sits there, forming those flat, layered stratus clouds, or even fog. All right, so we've got these huge air masses, each with its own personality. And they're moving around. Their personalities are even changing. So the big question is, what happens when they finally run into each other? Well, that's when you get the fireworks. Now, when these air masses meet, they don't just, mix together like paint. They're too different. Instead, they form a distinct boundary between them, and we call that a front. Think of it as the literal front line in that battle in the sky. It's where almost all the really interesting weather happens. And for today, we're going to focus on the most dramatic one of all, the cold front. So here's how the battle plays out, in 3 steps. First, you have the approach. The cold, dense air mass, the aggressor, comes barreling towards a warmer, lighter air mass. Next, the undercut. Because that cold air is so much heavier, it acts like a wedge and just aggressively shoves its way underneath the warm air. And finally, you get the updraft. That poor warm air has nowhere to go but up, and it gets forced upwards really, really fast. As it shoots up, it cools down, and bam! All that moisture condenses into those big, towering, dramatic clouds that can create some seriously intense weather. And when I say aggressive, I mean it. The slope of a cold front is steep. We're talking about a ratio of 1 to 50. To put that in perspective, imagine a ramp, but for every 50 feet you walk forward, it goes up 1 foot. It's like a plow pushing through the atmosphere. And it's that steep angle that forces the warm air to rocket upwards so violently, creating those really sudden and often turbulent weather changes. All right, the battle is over, the front has passed. So what happens next? Well, just like any battle, it leaves clues behind. And as a pilot, your job is to be a detective and read those clues in the sky. And here's what you'll find. First, and most obviously, the temperature will drop. Makes sense, right? A cold air mass just moved in. Second, the wind will change direction, sometimes pretty dramatically. Third, your barometer will go up. The air pressure rises because that new cold air is heavier. You might get some nasty showers or thunderstorms right as the front passes, but the good news is, what's left behind is often beautiful, clear, crisp air with fantastic visibility. So let's bring this all together from a pilot's perspective. It's all about reading the story of the sky. This isn't just textbook stuff. It's about putting all these clues together so you can see the big picture and know what's coming next. This quote really says it all. The weather you're flying in right now is a mix of two things: what that air mass was like where it was born, and what happened to it along its journey. If you can understand its origin story and its travel log, you can predict what it's going to do next. That's the key. And really, this is the most important takeaway. Weather is not random. It might feel like it sometimes, but it's a predictable system of cause and effect. It follows rules. And once you understand the personalities of these air masses and how they duke it out at their boundaries, you stop being a victim of the weather. You start reading it, anticipating it, and staying one step ahead.
So now you know how to spot an air mass and its front. But that's really just the beginning. How do these simple battle lines grow and twist and evolve into those gigantic swirling storm systems that we see on the weather map, dominating the forecast for days? Well, that's a whole other level of the story, and something we'll have to tackle next time.